on a question from a friend of the channel, we will present a group of videos. Each one will address one type of instrument and how we can create the hookup drawing for it. So I thought that in the beginning we need to agree what we will include in those drawings and why we need them and how we will develop them. So this video will be very short, just to understand what we are going to address in the coming videos. So what is a hookup drawing? Hookup drawing is a drawing we give it to the site contractor or the field contractor to address how he will install and connect a device, a pressure transmitter, a temperature transmitter, DP, whatever. So that is the main idea of this drawing. So what you expect to see in this drawing? The mechanical installation of the device, how you hook it up or you connect it to the process, the connection to the electrical pieces, the utilities, if there is any, like the air, power supply, the water, the gas, if there is any vent or drain, and also if there is any consideration for storage, handling, flushing, calibrating, all those stuff. So that's we expect to see some of them or all of them, it depends. One key element also we include in the hookup drawing is the demarcation of responsibilities and also who is going to supply what. So in this drawing here, in this piece, you can see that this is a line, this is a pipe, and there is a valve, we call it isolation valve, and anything below this valve, including the valve, belongs to mechanical or piping group, even the installation. Anything above the valve is the instrumentation. So this is the scope demarcation. Supply scope. In the drawing, here we said item 1, 2, 3, 4, the quantity, the part number, and then the description of each one, and then we'll see who is going to supply the pressure transmitter. It's a free issued to the site contractor. The three-way manifold, we decided the site contractor will buy the 316 stainless steel tubes, site contractor will provide it. So again, this could be part of the hookup drawing. So who is using this drawing? Who are the users? First, we said site contractor. What is used for? How to install all the devices, but also if there is anything he needs to buy, he will make the bill of material for that equipment. The EPC will see what's lying their scope and they will buy those parts. The client, the EPC, PMT, they will review this drawing and they will accept it, and then when the stuff had been built in the site, at the site, they will go and acknowledge and receive those equipment based on the installation drawing, which is the hookup drawing. So in a project, who prepare it? The first piece is, do our client has a hookup drawing? If the client has a hookup drawing, then let's use it. We may modify it if needed, but if not, just use it. This will unify all the client's sites, so everything will look and feel the same. If there is no hookup drawing for that specific instrument, then the project INC will develop this hookup drawing. Where to start? Your starting point is the vendor instruction manual. Then you have to modify it to suit the application. First, you look at the best industrial practical practice, and see if you need to modify it. And this is very important to look at the codes and the standards if you need to add, remove something from the manual instructions. So we have to follow some stuff: the company or the client standard, the vendor specification and installation manual, the codes, and so on. So we have to be careful which one override which. So that is very important to know which one you have to use first and which one will override whatever had been done before. So if the codes say you should not do this, then if the company standard say do it, if the vendor asks you to do it, no, you will not be able to do it, because the codes applicable in this country, in this place, in this industry said no. So the only thing which is can override everything is the codes and the country standards. So you have to be careful, not only in this type of drawing, but in all your design of something called Swiss cheese model. Assume there is a risk or hazard is not addressed by the vendor drawing or an installation manual or manual instruction and so on, and it's not addressed by the company or the client internal scope. Maybe this is something new, they never been using this, and also there is no practice for it. That means the risk is actual risk and something is going to happen. This is, I can't tell you what you can find following this model, but this is, we always keep it in mind. I will give you an example for that. The vendor do not, in most of the cases, the vendor do not care about the temperature of your pipes and tubes. Some companies, they said any pipes, tubes, temperature which above 60 degrees C within 2 meters from the ground level should be insulated. Here what they're looking for is protecting the people walking by, the technician, whoever is there in the site. He may touch the pipe and the pipe is very hot, they can have any accident there. So to avoid this, they said blank statement, anything more than 60 degrees C within 2 meters from the ground, insulated, regardless of the application. Now, if you find this somewhere, that's fine, but this will not be in the vendor's installation drawing. Typically, it's not in the code. So something like that, it will not be addressed unless someone in the company went through it and then advised us not to do it. So because the pressure transmitter and the flow and the temperature and the level, each one has its own hookup methodology and methods, we will address each one of them in a separate video. This video just putting you on the very first step of developing your own hookup drawing. In the next video, we will go with the pressure transmitter as our first hookup drawing development, and see you in this video. Thank you, and don't forget the share and the like.